What are the different types of energy? You can remember the different types of energy by Geek's Lunch. Now, the U doesn't actually stand for anything, so we can just cross that one out, which makes a nice word. Gravitational, electric, elastic potential energy, kinetic, sound, light, nuclear, chemical, and heat. What energy changes happen in a light bulb? So we're going to have electrical going in, and then coming out we are going to have light, which is our useful energy. We're going to have heat and sound probably, which are not useful energies. What energy changes happen in a TV? Again, we are going to have electrical going in. Heat is going to come out as our wasted energy, but then we are going to have light and sound coming out as our useful energy. What does the word system mean? It is a set of things that work together. And these are generally enclosed. The law of conservation of energy is that energy cannot be destroyed and it cannot be created. What is the equation linking kinetic energy, mass and velocity? So, kinetic energy is half mass velocity squared. What are the units of velocity? Velocity is measured in meters per second. What are the units for mass? Mass is measured in kilograms. What are the units for energy? Energy is measured in joules. What is elastic potential energy? This is stretching energy, so energy that's stored in like a hairband, an elastic band or in a bungee cord. What is the equation linking elastic potential energy, the spring constant and extension? Elastic potential energy equals half the spring constant extension squared. What are the units for elastic potential energy? Joules. What are the units for the spring constant? That is newtons per metre. What are the units for extension? Metres. What is gravitational potential energy? That is falling energy, or the energy that something that is about to fall has. What is the equation linking gravitational potential energy, mass, gravity and height? That is gravitational potential energy equals mass times gravity times height. What are the units for gravitational potential energy? Like all energy, that is measured in joules. The units and the value for gravity is 9.8 newtons per kilogram. What are the units for height? Height is measured in meters. This symbol is the symbol delta and it means change. So delta T would be change in time, or change in energy would be delta E. What is specific heat capacity? That is how much heat something can hold or absorb. What is the equation linking change in energy, mass, specific heat capacity, and change in temperature? For this equation, we're looking for change in energy equals mass times specific heat capacity times change in temperature. What are the units for energy? Energy is measured in joules. What are the units for specific heat capacity? Slightly nasty one here. That is joules per kilogram degrees C. You'll notice in here this is a space. What are the units for changing temperature? That is degrees C. What is the equation linking power, energy and time? That is power equals energy divided by time. What are the units for power? Units for power are watts. Units for time are seconds. This is an area that they might try and test you in the exam by giving something to you in minutes, hours, or even days. What is the equation linking power, work done, and time? That is power equals work done over time. What are the units for work done? Work done is measured in joules. What happens to waste energy? It dissipates into the surroundings. How can we reduce waste energy? We can reduce it by a number of ways. We can reduce it by reducing friction, so we have things rubbing against each other less. We can reduce it by insulation. This is a common one in houses, so that we don't lose heat out of windows. Give 3 examples of insulation that can be used in a house. So we can have loft insulation, we can have cavity wall insulation, we can have carpets, we can have glazing, curtains, draft excluders. You can put a hot water jacket on your hot water tank. Why is this system not 100% efficient? Every single system will in some part generate heat, and that is going to be wasted energy, whether that's heat from the electricity, heat from the friction. You are going to get heat somewhere. What is the equation for working out efficiency? Efficiency equals useful over total, whether that is useful power or whether that is useful energy, it's still the same equation. That is useful over total. What are the units for efficiency? This is not necessarily a trick question, but a slightly nicer question because there are no units. You can give your answer as a decimal or as a percentage, but do not under any circumstances, unless it's the answer, write that and mix up your decimals and your percentages, because that's, I'm afraid, is just wrong. Different ways we can get energy, so that can be solar, wind, hydroelectric power, geothermal, loads and loads of different ways we can get energy, and you need to know about all of them in detail. Whereas a renewable resource, that is one that doesn't run out. And a finite resource is one that does run out. There we go, guys. Some quick questions to help you with that topic. Draw the symbol for a cell. Cell. Battery. The difference between a cell and a battery is cell is just one, whereas battery is more than one cells put together. Symbol for an ammeter. Where must an ammeter be placed in circuit? It must be placed in series. It will not work unless it's placed in series. A voltmeter, and a voltmeter must be placed in parallel, so across a component like this. It will not work if it is placed in series. Symbol for a lamp, that's the one I just drew. Symbol for a diode, lots of things going on here, triangles, lines. Symbol for a resistor. Symbol for a light emitting diode. So we start off with our diode and then we have some arrows coming out. Symbol for a variable resistor. start off with a resistor and then we vary it. A symbol for a light dependent resistor. And then, because it is light dependent, we need arrows coming in. Symbol for a fuse. Remember, a fuse has a wire going all the way through it. Symbol for a thermistor. Draw the symbol for an open switch. Draw the symbol for a closed switch. What is the difference between series and parallel circuits? With a series circuit, you can run your finger all the way around it, whereas with a parallel circuit, you can't. It looks a bit more like a ladder or bits going in parallel or branches. Charge is the amount of electricity travelling through a circuit. Current is the flow of electrons measured in the circuit. What is the equation linking charge, current and time? For this we are going to have Q, which is our charge, equals current times time. The units for charge are coulombs, the units for current are amps, the units for time are seconds. The potential difference is what pushes the current around. And resistance is what controls the flow, so what allows it to go fast or what allows it to go slow. The equation linking current, potential difference and resistance. Potential difference equals current times resistance. The units for potential difference are volts. The units for resistance are ohms. Here we have our current potential difference graph. So we have potential difference and we have current, and for a conductor or a resistor it is going to be a straight line. Current potential difference graphs for a lamp. So here we have potential difference, here we have current, and this is going to be a slightly wavy line. Current potential difference graphs for a diode, potential difference, currents, and because the diode will only flow in one direction, it will go like this and then up again. How does resistance of a thermistor change as temperature changes? As the temperature increases, the resistance is going to decrease. How does the resistance of an LDR change as light intensity changes? So as the light increases, the resistance decreases. That's better. Current in a series circuit, no matter where you measure it, is going to be the same. How does potential difference behave in a series circuit? That is going to be splits between the components. How does resistance behave in a series circuit? You are going to need to add all of the resistors together to find the total resistance. How does current behave? Does current behave in a parallel circuit? This is going to be split across the branches, whereas potential difference is going to be the same. Slightly different, the resistance in a parallel circuit, if you want to find the 1 over the total resistance, you need to do 1 over each of the individual resistors added together. What is the voltage of major electricity in the UK? That is 230 volts. The frequency is 50 hertz. What is the difference between alternating and direct current? Direct current just goes in one direction, whereas alternating current switches back and forth, going in different directions. Inside a plug, we have live, neutral, and the earth wire, and the safety features are that it is covered in plastic, so lots of plastic all over the place, and it has a fuse. What is the equation linking power, current and potential difference? Power equals potential difference times current. The units for power are in watts. There is another equation linking power, current and resistance. Power equals current squared times resistance. The equation linking power, energy and time. Energy equals power times time. The units for energy are joules. The units for time are seconds. The equation linking energy, charge and potential difference. Energy equals charge times potential difference. The national grid is a network of cables that send electricity around the UK. Step up transformers increase the voltage and step down transformers decrease the voltage. So they step up so that they can carry them more efficiently, and they step down the voltage so that it's safe that we can use them in our homes. Draw the arrangements of particles in a solid. In a solid, you are going to have particles vibrating ever so slightly around a fixed position. They are not going to move, they're going to be very, very close to each other, and they're going to be touching each other a lot. Draw the arrangement of particles in a liquid. In a liquid, they're still going to be very close to each other, they're still going to be touching, but they're not going to be in a fixed position. They are going to be able to flow over each other, so their positioning is much more random than it is in a solid, but still very close to each other. Draw the arrangement of particles in a gas. In a gas, the particles are going to be very, very widely spaced. There's going to be lots of space between them. They're going to be moving very, very quickly. So they might bump into each other, but they are not generally touching each other. Density is how much matter or how many particles you have in a set volume. The equation linking density, mass and volume is density equals mass over volume. What are the units for density? Density is measured in kilograms per meters cubed. The units for mass are kilograms, and the units of volume are meters cubed. What is specific heat capacity? This is the amount of energy that something can absorb and hold on to. What is specific latent heat? This is all to do with the energy taken out or given in when things change state. What is the equation linking energy change, mass, specific heat capacity and change in temperature? This is a slightly tricky one because there's quite a lot of bits involved in this. But change in energy equals mass times specific heat capacity times change in temperature. What are the units for energy change? Energy change is measured in joules. Specific heat capacity is measured in joules per kilogram space degrees C. The units for temperature change are degrees C. The equation linking energy, mass, and specific latent heat is energy equals mass times specific latent heat, and our units for specific latent heat are joules per kilogram. What is the relationship, physics only now, what is the relationship between volume of gas and the pressure? So our pressure times volume, and there's going to be a constant in there. That's the next question. And what are the units for pressure? Pressure is measured in pascals. How big is an atom? An atom is very small, so it's about 10 to the minus 10 meters. The mass of a proton is 1. The mass of a neutron is 1. The mass of an electron is so tiny, we effectively say it's 0. Or you can say that it is 1/2000th, because that's how much smaller it is than a proton or a neutron. The charge on a proton is +1. The charge on an electron is -1. The charge on a neutron is 0. Protons are found in the nucleus. Neutrons are found in the nucleus. Electrons are found in the outer shells. When electrons absorb or emit radiation, they can move between shells. The atomic number is the smaller number of the two. Doesn't matter where it is located, and the mass number is the larger number of the two. And I'm not talking about font size here. Again, it does not matter where it is located. The number of protons is the same as the atomic number. The number of electrons an atom has is the same as the atomic number. You can find the number of neutrons by doing the mass number minus the atomic number. Atoms have no overall charge because the positive charges from the protons have positive charges, equal the negative charges from the electrons. So positive, negative, same number of each. Overall, that is going to be 0. Ions get charged when they gain or lose electrons, and an isotope has the same atomic number but it's going to have a different mass number. So it's going to have the same number of protons, but it is going to have a different number of neutrons. The plum pudding model stated that we had a big blob, and then within the big blob there were randomly distributed positive and negative charges, kind of like a Christmas pudding. And Rutherford disproved the plum pudding model, and he was one of the people that started coming up with the nuclear model of the atom. Bohr was the actual one who came up with the nuclear model. Chadwick discovered neutrons. Radioactive decay is where an atom is going to lose alpha, beta or gamma radiation on a completely random basis. The units for radioactivity are becquerels. The 3 different types of radiation are alpha, beta, and gamma. And a half-life is the time it takes for half the radioactivity held within a substance to decay. Last few questions for physics only. What are the sources of background radiation? We can have radon gas, space, loads and loads of things around us, X-rays, airline pilots are going to be exposed to more radiation because they travel higher up. There are a large number of things that contribute to background radiation. Nuclear fusion is the fusing different atoms together, and nuclear fission is splitting of a nucleus.